Okay, let us go over the questions quickly. I thought it was a particularly easy quiz this time around. Let's see. Alright, so the first element of an array can be found at index 1. Index 0. The keyword dash is used to create a new, create an array. New is the answer. Array initializer list is enclosed in braces. Yeah, array initializer list means that you give the default values to start with. So it goes something like, let me write it down. Something like this. So this will be the default values that you'd have in the array. This is called the initializer list, and that's enclosed in the braces, not in square brackets. The length of an array can be found with what? With or without the parentheses? A, right? The enhanced for loop iterates through the elements of an array without using the right answer will be counter, but I'm willing to accept variable or any such thing that gives an idea of index, counting the index. Like you don't need integer I, set it to 0 and go I++ like that. Okay, the enhanced for loop can be used only to dash array elements. It cannot be used to dash elements. So there are two fill in the blanks, one over here and over here. Obtain and modify, that's the answer. If you're confused with any of these things, please let me know. I can explain why this is the answer. Through enhanced for loop, you can actually get any particular element of the array, but you cannot make changes to that. Obviously, this choice is bad. You cannot modify them. That's the thing. This one says you can modify it. It says you can add, but it's not obviously possible because if you are talking about an array, you cannot add elements to it. The size is fixed. You cannot remove elements from there. So it's not even a choice. If we try to access an element that's not within the range of an array, we get what? We get an exception, right? So if we just write exception, I'll take it for an answer, but the answer that I was expecting was something very specific. Okay, so this is what I was expecting. If you write just exception, I'll accept that also. Okay, so to pass an array argument to a method, specify the name of of the array without what? Without the brackets. That's what we do. It's actually the brackets, not the parentheses, because we usually write, we write arrays with brackets, square brackets, not parentheses. Parentheses means it's round ones. To access an element at index I from an array list, we use the what method? The data type of the content of an array list is put inside the angular brackets, right? So how did we do? How many of you got all of these correct? Okay, that's pretty good. 9 correct. 8. Right. Okay, so that's with the quiz. So let us talk about something fun then. How many of you have played cards? Any sort of card games? Tash. That's better. Okay, so that's what we will talk about today. I mean, not particularly about gambling, but it can go along that line as well, because the game that I'm going to talk about is called poker, particularly Texas Hold'em poker. It's not so popular over here in the Indian subcontinent. We usually play 3 cards more, but poker, it's a 5-card game. It comes with a lot of variation. If you don't know about poker, that's not a problem. I'll go through that and we'll see what we're going to go with. Okay. So the playing cards themselves, I think even if you haven't played card games, you at least know them, or you have seen their faces, right? They come in 4 different suits. We have the hearts, we have the diamonds, we have the spades and the clubs. So 4 different suits. Those are called suits. And in each of those suits we have how many cards? 13 cards per suit, and altogether 52 cards. So, well, this is a wiki, it talks about the history and everything. I'm not really interested about that. Let's look at the modern one, if we can find them here. So yes, hearts, diamonds, clubs, and spades, those are the suits. And the 13 cards that we have, where are they? Well, I think I can get the standard 52 cards. There we go. All right. So the names are up here. We got ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, and king. In certain card games, ace is placed right at the end. It's valued more than the king. So, for example, in poker or in 3 cards, what we'll see is that ace is actually valued more than the king. So it would be placed right at the end. But in some of the games, it's actually valued as 1. So that's where it stands right over here. So as you can see, that some of these things are numbered, some of them are not, but they are all placed in a sequential order. We need to find a way to represent these cards, because what I want to do in today's lab class, I will give you some base code, or at least give you some hints. This is actually based off the topic from our textbook as well. If we read through chapter 7, they had a code implementation for card games. What I want to do over here is to evaluate a hand. So in poker, I'm not going to go into details, but what you have is you'll have 5 cards in you. Okay, you have 5 cards, and depending on what you have, this is your hand. The 5 cards, that's your hand. And depending on what you have in your hand, you can either win or lose. Basically, we're going to compare. Let's say I'm playing with another player. I'm going to compare my hand with that player's hand. And there can be many different variations of it. So, for example, right over here, this one says that this is the this is part of poker. So over here it says while flush, it will have the highest value right here. Okay. And it has to be the ace-high straight flush. So you have to go from 10 all the way to the ace for the same suit. Okay. And next comes straight flush. So over here you have a running sequence, right? 10 and then jack and then queen, king, and ace. Over here we have a running sequence again, but it's of a lesser value because it has lower ranked cards. And it starts low. because this one starts from 3, right? So this will have less value than this hand. Then we have 4 of a kind, where we have 4 cards of the same face. They're all jacks over here. Okay. You could also have 4 of a kind with 4 2s. That's also possible. We could also have a 4 of a kind with 4 5s. Not a problem. Okay. And then we have a full house where you have 3 cards of the same face and 2 cards of another face. Is this thing clear? I mean, here we have a total description of what you can do, well, how these cards are evaluated. So what I was saying is that in Indian subcontinent, like in Bangladesh, we play 3 cards more. So we play with 3 cards, not 5. And then for us, things are a little bit different. Like we don't go for royal flush like this. I mean, even if we go for queen, king, and ace, not for 5 of these. We also have the concept of straight flush. We don't have 4 of a kind. What we do have is 3 of a kind. Alright, so somehow, once you're given a deck of a hand of a card, you can evaluate that. And that's what I want you to do. That somehow we're going to represent a hand of a card, and I want to see if you can write methods that will actually test these things. You should be able to tell whether we have a royal flush or we have a 3 of a kind. Okay, you have to identify what type of hand this is, because if you can do that, then we can probably write some code that will help us compare to hands. And we're going to build on this exercise actually. Some of these things that the upcoming examples for interfaces, sorting, and other stuff, they will be built on top of this thing. It will be easier explained that way. And in today's class, what I want to start with also is something a bit new. And I usually leave it for later on, but I think it's a good time to introduce this already. So let me see if I can access our code base over here. This is our Java. So let us create a new project, and first of all, let me get rid of all these things. It's going to be a very simple Java application, a console application at that. Although you can obviously create a graphical user interface for a card playing game. I actually did that myself when I was a student. I wrote a 3-card playing game that we could play over the network, because when we friends got together, that's what we did. We played cards, 3 cards. And I wrote a game that we could play over the network with Java. I'm not asking you to do that over here, because we haven't covered all those things yet. However, we could still write a simple console application that somehow represents the concept of a card. So, how do you represent a card? Any card for that matter, what are the things you need to specify? Yeah, the name of the card, alright? So let's say ace of spades, that's the name of the card. What are the parts in it? The number is a part, okay, we call that face. And what else? and the term that you say spades, that's actually the suit, the type of the card, right? So we have two things. We have the face, and the examples can be 2, 3, 4, 5, and then we have jack, queen, king, and ace. So these are the faces, and what else we have? The suit. The suit is heart, diamond, spade. Okay. So if I were to write a card class, maybe I'm going to do it in this way. Okay? And in our main method, we can create cards just like that. So let us have a constructor that allows us to mention the face and the suit. The problem with this approach is that I am free to make anything that I would like. So for example, I can create a card, say C1 equal new card as ace of spades. The face is ace and the suit is spade. Right? So I could do that. Now the problem is I could also make another card and say this is going to be hello world. Okay. The second example makes totally no sense at all, right? But I give the user a total freedom of whatever he or she wants to write, because these are marked as strings. So whatever you can put in as strings, you can give the name of the card. And that's something we don't want to do. Excuse me for that. Sorry about that. So yeah, the thing that I was saying is that if you mention these things with strings, we run into trouble that we are free to type in whatever we like as the card needs. Okay, and we shouldn't have that freedom, because this is very much limited. We have only 13 choices over here, and we got 4 choices over here. This is fixed. And Java has a very nice feature for doing that. We also have the same feature in C++. This is called enumeration. So let me show you how we do this in Java, because I can't show that in C++. So I can, but it's not a topic of this course. So let's say we want to define the suits, the 4 different suits we got. Okay. We will create a enum. So previously we were writing class. Instead of that, we are going to write enum. And see, the suit names are written over here. We're going to use those names, and by convention for enumeration, since these things are constant, they're not going to change. Enumerations are all objects, but they're constant objects. No one can change them. So we're going to write something like spades in uppercase because it's a constant. If we want to define another constant of suit, we're going to put a comma and then write the next one, which is going to be, let's say, clubs, hearts, and diamonds, right? So we're done over here, and to show that we're done, we could just leave it like this, or we could put a semicolon over here. So both are okay. Now once you do that, see, the benefit of this is that now instead of saying we have a string suit, we're going to write it as we have a suit. That's a new type, and the type is enumeration. Okay. So that also means that we cannot use this constructor anymore. This one expects we use a string, but instead of doing so, we have to use this one now. Now, as soon as you do this, you can no longer write your own name for the suit. What you'd have to do now is you're forced to write suit dot, and then you get the choices. So you cannot go outside these 4 choices that you got. So if I want to pick spades over here, that's how I do. And that also stops me from writing world over here. Now I have to choose one of these. So hello hearts, for example. Is this thing clear? Let us also print this out to see how they come out. We can type in system.out.println, let's say C1, that will print the first card, and then we can also print the second card. Let me just run this project, and you'll see that we get cryptic output. These are all hash codes. They don't mean anything to us. What would be better is if we have a method that says public string to string. This is an inherited method that we are overriding. We talked about this in class, right? We're going to override this. We're going to say the face first. So return face of suit. Okay. So if you do that, it says ace of spades. It says hello of hearts. I mean, this one doesn't make any sense at all. But that also tells you that since you have 13 fixed set of choices, it's very easy to make a enum out of it. Since we can make an enum out of suit, can we then also make an enum out of the face? So for example, we could have 2, not a class, enum in lowercase, and then let me put my caps lock on, 3, 4, 5, 6. Something like this. Easy stuff, right? All these things are defined, and now if you go back to your card type, what's that? Which line? Oh, okay, right over here. Yeah, either you put a blank over here or put a semicolon over here. Comma, well, yeah, comma is also allowed, but I mean, it doesn't really make sense because It seems like we're expecting more enums over here, but we are not. So to signify that this is the end, you can put a semicolon or leave it blank. Both are okay. Our comma is also okay. Syntactically speaking, that's also valid. So as you'd imagine over here, we are going to say that we have a phase space, and that again tells us that you need to change the constructor. Okay, so we are defining the phase and the sweep. Now the example that you have in your textbook, it's different because they're not using enums. But I thought it's a good time to introduce enums over here because they come with a lot of advantages. Okay, so now we cannot access them like this anymore. We are going to say that this is going to be phase dot ace, for example, and again phase dot whatever you pick, right? So if you run the project now, it says ace of spades, four of hearts, and so on. Is this thing clear? Now the next thing I want to introduce over here is called a poker hand. How many cards do we have in a poker hand? 5. Okay, so these are the poker hands. Okay, I'm going to post a link over here. So these are the poker hands. Since we can have 5 cards in a poker hand, how do we represent this? What would be a good data structure to represent 5 cards in a poker hand? An array. Just like that. Okay. I mean, you could say that private card 1, card 2, card 3, something like this. But it's really not going to help you much because you won't be able to sort the cards or to check whether they are straight, like they come in a series, 2, 3, 4, 5 in such an order. You cannot check that. It's going to be very difficult to write codes in that way. So once we have that defined, let us create a constructor. How do we create a poker hand? There will be 5 cards in it. We know this already. And if you have gone through chapter 7, you know how to create an array, right? So cards equal to new card. How many cards? 5. That's what we write in the square brackets. So this is our poker hand, okay? And then we can put in some cards into it. Okay, let us put in some cards. Let's say there is a method that says add card, and we can add a particular card, let's say card C, and we will put that into a particular index. Of the void add card. So how do you type that in? We'd say cards at index equal to C. Maybe a specific. So that allows us to put a card at a particular index. And if I want to print out this entire hand, what I can do now is I can write a toString method, public string toString, we're supposed to return a string, so let's say the output is this, and we're going to run a loop through all my cards starting at 0. And less than how many cards we got? 5, but we can also say cards.length. We already know that from our quiz. And we can say output equal to whatever I had in output plus this new card plus a new line. And then you go to the next card. And finally we can return this output string back to the column. So what I want to show you over here is, instead of creating one card and two cards like this, let us create 5 cards and put them in a poker hand. Can we do that? So something like this. Let's say poker hand 1 equal to new poker hand. We call the constructor, and then we're supposed to add some cards into this poker hand. How do we do this? Hand 1 dot add card, and now we're supposed to add a card over here. So this is where we can pass a card, new card. We have to mention the face. So let's say face dot, let me pick some random ones. And Watsu, let's say diamonds. Oh, at index 0. So that's that. Now I can put other cards over here at index 1, 2, 3, and 4. I got all 5 cards. They're not supposed to be the same, so let me make some changes over here. So that's a poker hand, all right? And if you want to print that out, we can just say system.out.println and 1. So you print all these cards. Is this thing clear? Okay. I want you to write some methods that will help us understand what type of hand we have. And the types are over here. Is this thing clear? These are all defined types. So if you know that these are all defined types and it's not going to be anything different, what you can do now is you can then create another enum and say hand type. Okay. What are the hand types? We got royal flush. We got straight flush, 4 of a kind, full house, flush, straight, of a kind, two pairs pair, and card. Okay, so these are all the card types. What I want you to write, I had to go through all these things just to set up the context. I want you to write one simple method. It's not so simple after all. So you're supposed to find the hand type of a card, and over here I'm just returning null over here. And what we're going to do in the tester part, we can say system.out.println and 1.get hand type. So we want to find out what's the hand type of a particular card. So all these things, just to set up the task itself, This is what you're supposed to write. And I'm going to give you one simple example of how you can check this thing. So, for example, let's say I want to find 4 of a kind. How do we get this hand? This 4 of a kind, how do we get this? Yeah, 4 cards of the same suit. Okay, we have to have 4 cards of the same suit. So how do you implement that? Oh, okay. That kind of sucks.
Just put it line.
বন্ধ করবো কিভাবে রেকর্ডিংটা সেটা হলো কথা।
ঠিক আছে উপরে দিছে
So we haven't lost that. So if you look at 4 of a kind, I mean the suit needs to match. But the problem we have is that, well, the cards don't have to be ordered in a particular way. So even in this example, we can have well, actually for 4 of a kind, it's not the suit, it's actually the face. So if you look at the face, we have to have the same face 4 times. We may have a jack over here, 2 in the next place, and then the remaining 3 jacks after that. Okay, the ordering of these things are not in our hands unless we sort them beforehand. So that's the thing. We need to know how many cards of a particular face we got, how many jacks we got, how many 2s we got, how many queens and kings we got. We need to count them. And if any of those counters reach 4, we would say that's 4 of a kind. Is that clear to you? So what we can do now, see if it makes sense. Let us talk about a very simple scenario. Let's say there are only 3 different faces, 2, 3, and 4. If you understand that it works for 2, 3, and 4, you can go up till 13 cards, no big deal. What I'm proposing is that let us create a counter array to count how many 2s we got, how many 3s we got, and how many 4s we got. So in terms of index, array index, this is 0, this is 1, and this is 2. But we will consider this to be 2, this one to be 3, and this one to be 4. So let us say we got a poker hand where we have 2 of spades, 3 of clubs, 2 of hearts, 2 of diamonds, and let's say 3 of diamond again. Now if that's the scenario, what are we going to do? We're going to go through each and every card one at a time. Okay? We're going to go through each of them. So what's the face? That's 2. What are we going to do? We're going to increase the counter of 2. The next one, that's 3. So we're going to increase the counter of 3. And then we got 2. We're going to increase the counter over here. We are going to increase the counter of 2 over here. And the very last one, we're going to increase the counter over here. Just by looking at the tally, you can say that there are 3 2s and 2 3s. Is this example clear? So, right. So we got this example. If you look at these indices, that's something different. But if you just look at these values, we're counting how many 2s we got, how many 3s we got, how many 4s we got. And in any of these counters, if you find 4 anywhere, then you can say that this is 4 of 25. Is that clear? So how do you write this in terms of coding? We got all these cards in an array, so that tells you that you can actually run through them in a loop. Okay. Then how do we find the phase value from there? We can use dot phase. The next problem is how can you find the index for a particular phase? So for 2 it has to be 0, for 3 it has to be 1. For 4 it has to be 2. We need to find the index somewhere. So all these questions can be answered one at a time. And here is an example of how we can pick 4 of a kind. So first up, we need to set up the counter array. How many faces do we have? Different faces? 13, right? We got 13 different faces. So first of all, to create this counter array, it has to be an array. So it's an array. Counter equal to new. This is of integer type, and we're going to type in 13 over here because there are 13 different faces. Or since we have defined this as an enum, you'll see the beauty of it. You can actually say face dot values that gives you the entire array. See, it returns an array, and then you can type in the length to know how many cards are there. So in future, if you have new faces, you don't have to change this code. It will get auto updated. In terms of 13, in place of 13, you get 14 automatically. So that's actually better in that way. So now that we have created this counter, initially they will all have value 0. Okay. What are we going to loop through? We have all these cards, so we have to loop through each and every card. So for example, for int I equal to 0, I is less than how many cards we got? Cards.length, that will tell us that. I++. For each of these cards, what are we going to do? We want to find the face. The face of a card can be found by typing get the ith card and then get the face out of it. See, that doesn't work. Why? Because in the poker hand, actually the card data type, these are all private, so we cannot access them. What we need over here are the getters. So with the get methods, you can have get face and get suit. So if you go back to this code, we can say get face. So now we know the face. And once you know the face of a card, what can you do with that? There is a very nice way to find the index, since these are all enumeration, and that's the nice thing about enumeration. The first enumeration that you create will be index 0. They're all numbered, that's why they're called enum. Enum stands for enumeration, you're numbering them. This is number 0, this is number 1, this is number 2, and so on. These are all numbered. Okay? So let us just look at this. Int index is going to be face dot, there is a method called ordinal that returns an integer for you. And let me show you how this works. You need to see this first. This will allow the printer, and I'm just going to print the index over here and see what happens over here. Let us just run this project without doing anything at all. Let us try to make sense out of it. We got 5 of diamonds, we got 6 of diamonds, 9 of hearts, jack of clubs, queen of diamonds. See, for 5 of diamonds it says 3. Is this okay? In terms of our definition for faces, this is 2, which is at 0. This one is at 1, this is at 2, 5 is at 3, this is at 4, 5, 6, and 9 should be at 7. Okay, so if you look at the output now, where did we have 9? Right here. That's where we have 7. We had 5 over here and we have 3. For 5 we got 3. Is this thing clear? So this is enumeration, and it helps you number things in a very easy way. Now that we know the number, what we really need to do is in our poker hand. So this is working. We can go to the counter. We can go to that particular index, and then increase the tally, increase the count of that particular index. So if you do that, let us print out the counter values just to test it out. For int I equal to 0, I less than how many cards we got, well, counter. I plus plus, let us just print them out. System.out.println and print the index. Let us put a colon over here so that we can track, and then put the counter value right here. So just for this space, we can see we got 1 5, 1 6, 1 9, 1 jack, 1 queen. This is for ace, this is for king. Is this thing clear? So let us change things a little bit. Let us go back to the card game, and let's say we got 5 of hearts, we got 5 of clubs, and let's see if we get different result in our counter. Yes, we do. We got 3. Is this thing clear? And let us make it a bit obvious. So which one is missing right now? We got the 5 of diamonds, we got the 5 of hearts, we got 5 clubs. So only the spades are missing, right? And if you run this now, you get 4 right there. So how do you detect 4 of a kind? See, once we are done with this thing, in this counter, we can run through that for int I equal to 0. I less than all the counter that we got. If we have counter I is equal 4, it has to be 4 of a kind. If you don't have that, then it's something else. So right now, if you run through this, it says that the card type is 4 of a kind. Okay. Is this example clear to you? For the other ones, I mean, things are definitely going to be different. Like if I ask you to find out whether we have a straight, that means that you have to find things in a series. It's not too difficult. You can actually find a straight without sorting. Sorting makes it a little bit easier, but if you understand this concept, you can actually use part of this code to find out whether you have a straight or not. Try to understand how you do that. And for the other hand types, I have only done code for 4 of a kind. I haven't done any of that. You have to go from the top. So if something is a royal flush, you're not going to say high card for that. High card shouldn't be a T-bin. Okay. So yeah, definitely for a royal flush, you can also consider that as a high card, but you're not going to do that. Read through the description. I'm not going to go over the open hand types in class. I don't have enough time for that. I'm not going to ask you to do this. Today's class is going to be different. Like, usually I give you guys some class when you do that. But I would be able to do it quickly. Do that. So I would expect that you put some effort to this thing at home, because a lot of our examples for the subsequent classes will build on it. So if you don't understand this one, the next few classes are going to be difficult for you. But please try to get this part done at least before our next class. I will upload this code. I'm asking you to write this method. At least it gets you in things. So I want to see if we can write the logics to find the hand type of a poker hand. And this is only for 4 of a hand. Is the task clear? I've also posted a link over here that takes you to this site. If you read through the description, it should be pretty clear how you can evaluate a poker hand. Okay? Any question about any of these? So in next class, what I will start with in the theory class, I will go through the exam questions, what sort of answers I was expecting for that, and then we can talk about this thing also. Right? If you have any problem implementing this thing, let me know in class so that I can look into that part. That's pretty much it for today's class.